In this unit, we're going to be discussing dimensional analysis, which is just a fancy word for converting units. And we're going to do a lot of different types of dimensional analysis. We're going to start out with SI units, then we're going to move to English units. We're going to do some with scientific notation, and then also with units in the numerator and the denominator. So it's going to be, probably under 10 problems, but it's going to be, problem after problem, kind of like bang, bang, bang. So we're going to start out with the easiest one, okay? We're going to start out with trying to convert 54 decimeters into meters, okay? And the way we do this, okay, we call it train tracks because we're going to make this kind of like horizontal line with some vertical lines, as many as you need on a map that might look like a train track, okay? And that's why we call them that. But we're going to put this unit, this number, the given, in the upper left-hand corner, both the number and the unit. And the idea of train tracks, or dimensional analysis, is to make sure that we're going to cancel out this given, okay, and put it into the unit that we want, which in this case is going to be meters. So in order to get rid of the decimeter, we're going to place it on the bottom. And if we have a unit on the top and on the bottom, they're going to cancel out. And then we're going to put the unit that we want to convert to on the top. Okay, now we do need the conversion factor between decimeters and meters. Most teachers are going to have you memorize kind of like a set of conversion factors. Okay, this is the set that I give my students. And all the numbers are going to have like positive exponents, because I always want them thinking in terms of, well, how many of the smaller units is going to make up one of the larger units, okay? And when I look up on this sheet, you look up that line that has decimeters and meters, and you're going to find out that it's going to take 10 of the smaller units of decimeters to make up one of the unit of meters. And to finish this problem off, I just have to get my calculator out. I'm always multiplying on the top and dividing on the bottom. So 54 times 1 divided by 10 is going to give you your answer of 5.4 meters. Okay, so I never put this answer in the train track. If I ever wanted to put it near the train track, I would do something like this. And that's a mistake that a lot of students will make, is they'll try to put this number, okay, and unit inside the train track. But the train track is just for us to take care of our units and making sure that they cancel out. Okay? So let's try another one. And when we do this problem, after I set it up, you can hit the pause button, okay, and pause the video after each setup, okay, and then try the problem, unpause it, and then check out the work that I'm going to do afterwards. Okay, so the next problem that I'm going to have, okay, is going to be 0.031 kilometers is equal to how many meters? Now remember, I'm looking for the setup. I know some students just memorize moving the decimal point left and right. Kind of works for some of our smaller SI units, but as we get into some of the bigger units and we start to incorporate scientific notation, or maybe even go English units, the setup is going to end up being very important. So I do want to see the setup even for these easier problems. Okay, so like I said, if you want to pause right now the video, you can try this problem, then check out the answer. Okay, but when you unpause it, we'll be working on the problem. Okay, so once again, we're going to draw our train track. We're going to take the given and put it in the upper left-hand corner. So it's going to be 0.031 kilometers. And the idea is to get rid of the kilometer unit. Okay, it's as a numerator here. So if I put it as a denominator, it will cancel out. Kilometers will cancel out. I want to convert to meters. I look up my sheet and I look up, well, how many of the smaller units make up one of the larger units? And you're going to find out that it takes 1,000 meters to make up 1 kilometer. Remember, we're multiplying on the top and dividing on the bottom. Okay. So if I take 0.031, multiply by 1,000, divide by 1, okay, you'll end up getting 31 meters as an answer. Okay. Now I've had some students say this, okay, well, Mr. Hoeffel, what about the significant figures? okay? We see like 2 sig figs here. Depending on your teacher, they may say this is 1 sig fig. Some other teachers might say, well, it's ambiguous. There could be 2, 3, or 4. We're not sure, okay? And down here's 1 sig fig. So why does your final answer have 2 sig figs if there's only 1 sig fig right here? And that has to do with that conversion factors are exact numbers. And that means there's exactly, perfectly exact, 1,000 meters for every 1 kilometer. And when you have exact numbers, okay, they are said to have an infinite number of significant figures. So basically, whatever your given is, if all of your conversion factors are exact, that's what your final answer has to be reported in. So 2 sig figs as your given, you're going to end up with 2 sig figs as a final answer. And if you don't know what I'm talking about when it comes to significant figures, I will have a video posted in the description that will lead you to a lesson that's strictly on significant figures. Okay, but this video is about dimensional analysis, so let's move on to some that might be a little bit more challenging. Okay, now the conversion factors I have my students memorize, it starts out with just distance, but if this was kilograms to grams, the conversion factors would work the same way. Okay, so it'd be a kilogram here, but gram here. So it'd be 31 grams for every 0.031 kilograms. Basically, I'm saying the conversion factors are exactly the same. It doesn't matter if it's in meters, in grams, or in liters. It just depends if you're talking about distance, mass, or volume, respectively. Okay, so this next problem is going to be 1.4 times 10 to the negative 2 gigagrams is equal to how many grams? Okay, so this is a pretty big prefix that we have here. Okay, so try the problem and come back and look at the answer when you're ready. Okay, but it works out the same way. 1.4 times 10 to the negative 2, and I'm going to put gigagrams right here. Of course, I want to get rid of the gigagrams, so it goes right here. And I want to convert to grams, so it goes on the top. So the gigagrams are canceled out, and I'm going to be left with grams. Now, like I said, okay, depending on your teacher, they're going to ask you to, memorize a certain number of conversion factors. And I do ask my class to go all the way up to tera and all the way down to picometers or picometers, okay? And when we look up the gigagrams here, okay, it says 1 times 10 to the 9 grams, okay, because it's going to take a lot of these guys to make up 1 of the gigagrams. So how do we put this in our calculator is sometimes a little challenging, okay? I see some students doing this as 1.4 times 10 to the negative 2. 1.4 times 10 to the negative 2. And if you do this, okay, eventually as we continue in advanced chemistry, okay, so we're talking high-level high school classes like an AP class or like college, first-year chemistry class, doing your numbers like this could get you into trouble because your calculator actually sees this as 3 numbers. They see the 1.4 number, and then you're doing some math. They see the 10 number, and then you're doing some more math. And then they see the negative 2 number. So actually your calculator is seeing 3 numbers here, and we want to get rid of that. We want to make sure the calculator sees 1 number. So I ask my students to use the exponential button on their calculator. So it's going to be 1.4e negative 2. And when you do this, your calculator sees this as 1 number. Okay, so PEMDAS is not going to get you in the future. Okay, if you use that exponential button. So in our calculator, I'm going to try to get as close as I possibly can. Hopefully this will show up, okay? But I'm going to do 1.4, okay? And I'm going to hit the second button, and then the comma that's right above the number 7 will give you that E, okay? And that E means the times 10. I'm going to do times 10 to the negative 2, okay? And in this problem, I'm going to hit multiply 1 times 10 to the 9, okay? So I'm going to hit multiply 1 times 10 to the 9th power, okay? And when I get that, I get this huge number. It's 1, 4, and then followed by a whole bunch of zeros. Now, you can count those zeros over and put your answer in as 1.4 times 10 to the how many zeros you move the decimal point over. But also, if you know a little bit about exponents, when you multiply them and they have the same base, you're adding the exponents. So negative 2 plus 9 is to the 7th power. Okay, so that's a reminder of some math that sometimes some of my students forget. So if I start out with 2 sig figs, I'm going to end with 2 sig figs. And that's going to be the 1.4 part. The times 10 to the 7th does not count for sig figs. Okay, so these are our first 3 problems. We got some pretty easy ones. We got prefix to a base unit, a prefix to a base unit, but here the number's in the denominator, here it's in the numerator, and we're always thinking about, well, how many of the small units make up one of the larger units? How many of the small units will make up one of the large units? Sometimes that number ends in the numerator, sometimes it ends in the denominator. And then we have a problem that does the same thing. It's just a prefix to a base unit, but it's using scientific notation, which sometimes gives people a little bit of a hard time. Okay, so instead of just going from prefix to a base unit, what we're going to do is we're going to go from one prefix to another prefix. So let me erase this, and we'll do a couple problems where we're going from one prefix to another prefix. For example, what if I wanted to go from 1.8 kilometers into centimeters? And what I'm going to do is set up my train track the same way I always would. I'm going to put my given in the upper left-hand corner like I always would. I'm going to bring this unit down like I always would. But I am not going to convert the kilometers into centimeters. When I look at my sheet of as far as conversion factors, I only have them memorize the prefix to the base unit. I do not have them memorize every combination of prefix to prefix. That would be way too much memorization. So we want to decrease the amount that we memorize and then expand on how much we understand conceptually. So all we're going to do here is we're going to do the problem in 2 steps. We're going to convert the prefix into its base unit and then just repeat that same process one more time. Do you see how we brought the kilometers down? We're going to bring the meters down so that they're canceled out, and then we'll go to the other prefix. So basically this is prefix to the base unit and then base unit to the other prefix. And if we do things this way, the only things we have to memorize is prefix to those base units, okay, and not every combination of prefix to prefix. That would be way too much to memorize. So to finish this problem off, it takes 1,000 meters for every 1 kilometer and 100 centimeters for every meter. Remember, we're going to multiply on the top and we're going to divide on the bottom. Also, you might start to figure out that these ones don't really matter, even if they're on the top, okay? Because if you multiply anything by 1, it's the same number. If you divide anything by 1, it's the same number, okay? So typically, we just do 1.8 times 1,000 times 100. Remember, we need to put this into scientific notation because we don't want any trailing zeros without a decimal point. Okay, because in my class, trailing zeros without a decimal point are considered ambiguous. We're not sure how well the person measured. Here you can see the person measured at 2 sig figs. So our final answer is going to have 2 sig figs, and we're going to be very strict on the way that we show that number as 1.8 times 10 to the 5th. Okay, so prefix to base unit to the other prefix. Okay, let's try this one more time, okay, but including that scientific notation. Let's say we have a number like 3.91 times 10 to the 6th power milliliters, and I want you to convert that into megaliters. Remember, there's a difference between lowercase m and capital M. This is milliliters. This is going to be megaliters. So like I said, you could pause the video, try the problem. When you come back, I'll be working on the problem. Okay. So we're going to put the given in the upper left-hand corner, and I'm going to convert milliliters into its base unit, which is going to be the liter. And then I'm going to repeat the process. I'm going to convert liters into the other prefix, okay, which is going to be megaliter. Conversion factor, there's 1,000 milliliters for every 1 liter, okay? And there is 1 times 10 to the 6 liters that make up 1 megaliter. A megaliter is very big, so a lot of the smaller units to make up one of the bigger units. We're going to multiply on the top, and we're going to divide on the bottom. Remember, I don't really care about the ones, so this is 3.91 times 10 to the 6 divided by 1,000. And what I have sometimes students do is they multiply these two numbers, but remember, if it's in the denominator, you have to divide. So in my calculator, okay, if I want to show this one last time with scientific notation, okay, the way I'm entering it is 3.91 using that E button to the 6th power, okay, divided by 1,000, divided by 1 E6, and when you look at the answer, it comes out to be 0.00391. 0.00391 megaliters. And I have students that say, hold on, Mr. Hoeffel, you need to put that into scientific notation. I was like, no, I really don't have to. I can if I want to, but it's not required. And the reason for that is this starts out with 3 sig figs, the 3.91. Okay? After I do all this, this still has 3 sig figs because leading zeros do not count as a significant figure. So there's nothing wrong with the way I wrote this number. If you wanted to, you could put this into scientific notation. And remember, since this is a small number, okay, it's going to be a negative exponent. So that'd be 1, 2, 3 places. So either of these answers would be legit, 0.00391, okay, or 3.91 times 10 to the negative 3. Okay, so this is how we handle prefix to prefix or prefix to prefix. Well, next question is, what if we wanted to incorporate some English units in what we're doing? Does this train track method only work for SI, okay, or will it work for English units as well? And obviously the answer is it works for English units as well. Let's say the problem was I wanted to figure out how many meters there were from goalpost to goalpost on a football field. And there's 120 yards between the two goalposts on a football field. Remember, the football field itself is 100 yards, okay? But then there's an end zone on both sides that are 10 yards, and that's where the goalposts sit, at the end of the end zone. So it's 120 yards from goalpost to goalpost, okay? Being American, we kind of know some of these English conversion factors. What I do for my students is if we're on a test, I only make them memorize that sheet of metric ones, okay? I do give them the English ones, but that's going to be up to your teacher, okay? So we had 120 yards, and I was trying to convert that into meters. What I would do is I'd convert the yards into feet first, okay? And I would help my students. I'd have somewhere saying, hey, there's 3 feet for every 1 yard, okay? But they'd have to enter it into the train track, okay? If we stopped right here, the yards would cancel out and we're left with feet. I don't want feet. I want to get to meters, so I keep working. I then go from feet to inches. As Americans, most of us know that there's 12 inches in a foot, okay? And then this is the one that a lot of students don't know, okay? It's inches to centimeters, okay? So this is an English to metric conversion. The reason why I like this one is because I know that it's exact, Okay, and if it's exact, I don't have to worry about the sig figs except the one that's in the given. So it is 2.54 centimeters to 1 inch. If you do not know this conversion factor, it might be one that I would write down, and I'd probably try to memorize that one because it's an exact conversion factor between the English unit and the metric system, and there's not too many that are perfectly exact. But from here on out, I would not provide any conversion factors because everything from here on out is metric. And my students are expected to know that there's 100 centimeters to every 1 meter. Okay, so if you look at this problem, the yards are going to cancel out, the feet are going to cancel out, the inches are going to cancel out, the centimeters are going to cancel out, and you're left with this unit meters. So this is kind of like a 4-step conversion factor, okay, using a combination of English and metric at the same time. And if you work this out, okay, you get a number, I think it's 109.728 meters. But remember, we have 3 sig figs in the beginning. So 1, 2, 3, here's my cutoff. I use that 7 for rounding. So I make my students write it like this because when you put the decimal point in here, we're saying that that is significant, okay? Some teachers may require you to put this into scientific notation. But in my class, as long as they put that decimal point in there, okay, trailing zeros with the decimal point is significant. Sorry, this one should be 1.10 times 10 to the second power in order to get the 3 sig figs. Okay, so either of these would be acceptable. All right, so this one dealt with 4 steps, okay, and included another measuring system, the English system, mixed in with the metric system. And the last thing that we need to do is talk about what happens if we have units as a numerator and a denominator. Okay, for example, what if I was given the problem 5.81 kilograms per centiliter, and I want to convert that into grams per milliliter? This one seems a little challenging, but actually if you start with the correct setup, it's actually very, very easy. Okay, so let's kind of get that set up right. Kind of walking in front of the camera there. But it's going to be 5.81 kilogram per centiliter. So as you can see, in all the other problems, we only used the top left, and that was because we only had units that were in the numerator. But now we have units in the numerator and the denominator, so we need to make sure we incorporate both the numerator and the denominator. And as soon as you set it up like this, everything becomes really easy, especially if you were able to handle some of those earlier problems that we were doing. So to do this, you just do 1 step at a time. I'm going to convert the kilograms into grams. Kilograms is on the top, so I need to put it on the bottom in order for it to cancel out and to be left with grams. If I stop the problem right now, the kilograms would cancel out and I'd have grams per centiliter. But I don't want grams per centiliter, I want grams per milliliter. So let's use some logic here. If I put the kilogram down here to cancel this one out on top, well, if I have a unit in the denominator as a centiliter and I want it to cancel out, I would need to have to put that on the top. And I'm going to convert the centiliter into the base unit, and then I'm going to get rid of that base unit by bringing it on the top and then converting it to the unit that I want. Okay, so if you look here, the kilograms canceled out, and I'm left with this unit gram. The centiliters cancel out, and the liters cancel out, and I'm left with milliliters on the bottom, grams per milliliter. The last thing I need to do is just put in my conversion factors. 1,000 to 1 for the grams to kilograms, 100 to 1 for the centiliters to liters, and 1,000 to 1 this way because it's 1,000 milliliters to make up one of the larger units, liters. Okay, and if I do this work, okay, I will get the answer of 581. Okay, so this is where we deal with the unit on the top and the bottom. Let's practice that one more time before we call it a day. What if the problem was 402? We're going to do centigrams per deciliter. And we want to convert that into a density that we're normally use, which is grams per milliliter. So same thing, pause the video, try this problem out. When you come back, I'll be working it. So we draw our train tracks. We put our number in, and then the unit in the numerator and the denominator. Centigrams per deciliter. And you just take care of one unit at a time. Take care of the numerator maybe first. I convert the centigrams into grams. There's 100 centigrams to a gram. And then I take care of the deciliters. Now, deciliters is on the bottom, so if I want to cancel it out, I need to put it on the top. Deciliters to the base unit liters. Put it on the top, get rid of the liters, and go to milliliters. This is going to be 10 to 1. This is 1,000 to 1. And as you can see, the centiliters cancel out. The deciliters cancel out. The liters cancel out. And I'm going to be left with the unit of grams per milliliter, like the problem said. So 402 divided by 100 times 10 divided by 1,000 gives me an answer of 0.0402. 3 sig figs to begin with, 3 sig figs at the end. If you really want it in scientific notation, 4.02 times 10 to the negative 2 grams per milliliter. Okay, but this I would accept. If you really want things in scientific notation, you could do it this way as well. Okay, and that kind of concludes our lesson on dimensional analysis.